Hello everyone, and welcome to the live code first lecture in the iterators and generators section of this course. So we already gotten a brief introduction of just the general concept of generators. Now let's actually make some generator functions to see how they work. So what I'm going to do is create a generator function, and it's going to look very similar to a normal function with one key difference being the yield keyword. So I'm going to call it GenCubes, and it's going to take an argument n. And then for num in range n, so n is going to be a number, I'm going to yield, not return, that num to the power of 3. And then I'm going to say for x in GenCubes, let's say 10, go ahead and print x. So if you notice what's going on here, since we have a generator function, we don't actually have to keep track of every single cube number that we created. So as I mentioned, generators are best for calculating large sets of results. So if I ended up putting some ginormous number here, yes, they would all print, which would be a little bit messy. But if I just wanted to do something with that number and not actually print it out, that would be a lot better than if I had a list return here. So the way this would look if it was a normal function, I would have some sort of list out and then be saying out.append that number. But you can imagine if I were to, at the end, return out and then say for x in GenCubes of 10, let's go ahead and run this. You'll notice it's the exact same thing, but Python's actually keeping out here in memory. So if this is a humongous number, you're going to run into errors or just general problems of your code slowing down. To show you a better example of this, I'm going to create an example generator that calculates Fibonacci numbers. So in case you're not familiar with Fibonacci numbers, you can go ahead and go to the Jupyter Notebook and click this link here. If you want, go ahead and pause the video so you can see what Fibonacci's numbers are. But basically, you can think of it as just an integer sequence where the last two numbers are getting summed together for the next one. So if you can zoom in here, check out this first integer. And in modern usage, they usually start at 0. But what you're doing here is saying 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, etc., so on and so on. So there's a lot of interesting patterns that you can check out on this page, but that's all you need to know as far as this lecture video is concerned. So going back to the lecture for the live code, let's go ahead and make a generator called GenFibon. It's going to take a number n, and it's going to generate a Fibonacci sequence up to n. So I'll make a equal 1 and b equal 1. So we'll go with that more classic starting point where it starts 1, 1. So that first line of that Wikipedia page. And then I'm going to say for I in range n, yield a. And then after you yield it, I'm going to say a is now equal to b, and then b is now equal to the sum of those two, a plus b. So now I can say for num in GenFibon 10, print num. And you'll notice here, we start printing. And you'll notice this sequence of numbers is actually incorrect. This is not a Fibonacci sequence. And I hope you spotted the error. The reason I showed this is because this is a common interview question mistake. But what's going on here is we need to actually assign a temporary variable. Since we're reassigning a to b here, this is actually a statement of just saying b plus b equals b. So what we can do, there's actually two ways to do this. I'll show you the more general way first. So I would say a temporary variable t is equal to a, then set a equal to b, and here I can have b equal to t plus b. And if I run that, now we have the Fibonacci sequence. Another way to do this is using tuple unpacking, and that will actually reduce this to one line where you can do the assignments at the same time, and that will look like this: ab equals b, a plus b. And you'll notice that's the same result. Just something to keep in mind, and we go over this tuple unpacking later on in the advanced tuples section of this course. Okay, just wanted to mention that since that's a common interview question, and it's also a common interview mistake as you're learning about generators. Okay, so moving along, we've created this Fibonacci sequence. So what would this look like if we wanted to create a normal function? Well, it would look something like this. I would have def fibon n. Let's go ahead and start it at 1 again. So a equals 1, b equals 1. Again, we can actually use tuple unpacking to do that assignment. A comma b equals 1 comma 1. But we won't do that for now. We have to assign an output list and then say for I in range n, output dot append a, and then do the assignment here. ab equals b, a plus b. And then at the end we return output. And then if I call fibon 10, I get the Fibonacci list sequence out. Okay, so notice again, if we call some very large value of n, you know, if I were to pass in a lot of zeros here, we would have to hold that entire list in memory, and we have to keep track of every single result. But for the generators, we only keep track of the current number in that sequence. So we don't keep track of every single result. Okay, so the key to fully understanding generators is the next function and the iter function. And this will really help you cement what's actually going on. So the next function, and it's literally looks like this, just next, allows us to access the next element in a sequence. So I'll show you through some simple examples. I'm going to create a function, or excuse me, a generator function, simple gen. It's not going to take in any arguments, and it's going to say for x in range 3, yield x. Okay, now what I'm going to do, since everything in Python is an object, I'm actually going to assign SimpleGen to the label g. SimpleGen, close it off, and then say print, and this is where the next function comes in. I'm going to say print next g. First one's going to be 0. If I do this again, print next g, we'll get a 1. If I do this again, notice I'm going to keep going up and up. So now I'm going to copy this, control copy, and I'm going to keep going until we get an error. Here we go, stop iteration. So after yielding all the values, so notice all the values was up to 3 here. So that was 0, 1, 2. So up to 3, we have a stop iteration error. So what this error informs us of is that all the values have been yielded. So you might be wondering, why don't we get this error when we're using a for loop? And that's because the for loop automatically catches this error and then stops calling next. So let's go ahead and check out how to use the iter function, which is iter. So you remember that strings are iterables. So for example, I could say s equals the string hello for let in s, printlet, excuse me. So I'm going to print every letter in that string. So we can iterate through a string since they're iterables, but that doesn't mean the string itself is an iterator. What we can do is check this with the next function. So for instance, if I wanted to say, okay, give me the next one of s, it'll say string object is not an iterator. So it's an iterable, which means we can iterate through it, but it's not an iterator itself. It's not returning stuff like a function. All right, so that's where the iter function actually comes into play. So the string object supports iteration, but we cannot directly iterate over it as we could with a generator function, unless we use the iter function. So I can say s underscore iter is equal to iter s, shift enter, and then we can call next on it, and you'll notice we don't get an error. This will actually keep calling everything until we've yielded all the values. And then we have a stop iteration error. All right, so now you know how to convert objects that are iterables into iterators themselves. Okay, I know that was a lot and some of it may have been a little complicated, but the main takeaway from this lecture is that using the yield keyword at a function will cause the function to become an actual generator. And this change can save you a lot of memory for large use cases. So for more information on generators, I actually want you, and this is a bit of a homework assignment for you, go to the Jupyter Notebook, scroll all the way down, and click these two links, a Stack Overflow answer and another Stack Overflow answer. And they're basically explanations on understanding generators. So if we look at these two links, I want you to go ahead and read here. Now note this post assumes 3.x syntax, but it's okay, you should still be able to understand it. And it goes through some of the similar explanations that I did of next and the iter function. So I want you to go ahead and read this Stack Overflow answer. I know it's a lot, but it's definitely worth it. And he also points out some 2.x changes. So that's your first assignment, is read that Stack Overflow answer. And then I also want you to read this separate breakdown on the yield keyword. So there's another great breakdown of iterables versus generators here and the yield statement. Okay, so your assignment is to, after you're done reading that Jupyter Notebook, read these two Stack Overflow questions, and that should complete your understanding of generators and the yield statement. Okay, so thanks for listening on to this lecture, everyone, and I will see you at the next section. Thanks, everyone.